A new study says there may be a lot more magma under Yellowstone than we thought, which could mean that it's not just a supervolcano, but a mega-ultra-supervolcano. So is this the biggest volcanic threat on Earth? What does broken even mean in this case? And what would happen if it did blow? Let's dive into some explosive science to find out. Yellowstone National Park sits atop a supervolcano, one of only a very small handful of such features on Earth. But recently, scientists have come to believe that it may be even more super than super. A 2022 paper published in the journal Geology claimed that Yellowstone could be the world's first mega-ultra-supervolcano, capable of eruption so big it would threaten the entire planet. But many other experts dismissed their work as pseudoscientific bunkum. Did this new research finally prove them wrong? To answer that question, we need to take a closer look at what makes a volcano super in the first place. Volcanoes are ranked according to how much they can erupt. A small volcano might only be able to eject 10,000 cubic meters of material during an eruption, whereas a large one might send 10 million cubic meters flying, and a supervolcano can eject over 1 billion cubic meters of material in a single go. For reference, that's about 10 times more material than was ejected during the 1980 eruption of Mount St. Helens in Washington state. Mount Mauna Loa in Hawaii, which scientists currently consider the largest volcano on Earth, has an eruption volume of around 60 billion cubic meters. So, while huge, it still falls short of that 1 billion threshold, so it's not officially a supervolcano. Yellowstone, however, is estimated to have a volume of over 2,400 billion cubic meters. That makes it a true supervolcano and the largest in the world. But what makes a volcano mega-ultra-super? And what did those authors mean by saying that Yellowstone is broken? It all comes down to how the magma moves underneath a volcano. Typically, magma starts off as molten rock deep within the earth, where it's hot enough to melt solid rock. But as it begins to rise up towards the surface, the pressure drops, and gases dissolved in the magma begin to come out of solution, forming bubbles. As these bubbles form, they make the magma frothy and increase its volume by up to 100 times. This is the same principle behind beer or champagne. As the gas inside the bottle dissolves, the liquid level goes down. But when the gas comes out of solution, either because the pressure is released or the bottle is opened, the liquid rises. The more gas in the magma, the more it expands, and the more explosive the eruption can be. Some magma chambers are well mixed, meaning the magma has a uniform composition and gas content throughout. But others contain layers of magma with different gas contents. In the worst-case scenario for our purposes here, the top layer has low gas content, and the bottom layer has high gas content. If that lower layer gets too deep, it won't be able to get enough gas out of solution before reaching the surface. And when it erupts, all that gas will come out at once. When that happens, the entire volume of the magma chamber gets ejected during an eruption known as a Plinian eruption, named after the Roman scientist Pliny the Younger, who described the eruption of Mount Vesuvius in 79 AD, which buried the city of Pompeii. And it's this type of eruption that could cause major problems for the rest of the planet. Studies published in the late 1990s suggested that Yellowstone had low gas content magma in its plumbing, implying that its eruptions wouldn't be particularly violent. However, findings published in 2008 showed that Yellowstone's magma actually contained significantly more gas than expected, leading researchers to conclude that the magma chamber was layered like we described earlier. Subsequent studies published in 2013 and 2018 confirmed these findings, showing that Yellowstone's magma chamber had at least 2 distinct layers with differing gas contents and that it had been refilling from below with hotter, more buoyant magma. All of this pointed to a magma chamber primed for a giant Plinian eruption, hence the mega-ultra-supervolcano idea. The 2022 study said that it had found evidence that Yellowstone had produced 2 Plinian eruptions in the past, and that its current magma chamber also appeared to have the right conditions to produce one in the future. They came to this conclusion based on geologic evidence left behind from previous eruptions. For instance, they studied rocks and ash deposits from older eruptions to determine the types of magma that were present and how explosive each eruption was. They also looked at the shape of nearby hills and valleys and used that information to infer the direction the magma traveled during eruptions. But another group of scientists argued that these methods were unreliable and that the original 2022 study had ignored a lot of available data that contradicted their claims. First, they pointed out that it's hard to tell the difference between Plinian and non-Plinian eruptions based on the geologic record alone. So it was possible that some of the features attributed to Plinian eruptions might have been caused by other kinds of eruptions. Second, they accused the 2022 team of cherry-picking data to fit their narrative, specifically highlighting the exclusion of a 2018 study that provided evidence against their interpretation of the geological record. Finally, they argued that if Yellowstone really was on the verge of a mega-ultra-super eruption, we should be able to see signs of magma pushing up through the crust, but we don't. Instead, the available evidence suggests that the magma chamber has been relatively quiet since the late Pleistocene epoch, meaning the last 2.5 million years. Now, the 2022 team has come back swinging with their own rebuttal. They argue that their earlier work wasn't intended to be a comprehensive analysis of Yellowstone's history, and that they didn't try to claim that their interpretation was the only correct one. They also reject the idea that they ignored existing research, pointing out that the 2018 study they left out didn't use the most up-to-date data on Yellowstone's geology. Finally, they stand by their claim that the existing evidence points to a mega-ultra-super eruption at Yellowstone in the past, and that the conditions are still in place for another one to happen again. So, what does this all mean? Will Yellowstone blow, and is it going to break the planet? Well, let's talk about that first part first. Yellowstone hasn't shown any signs of waking up anytime soon. There are swarms of earthquakes that sometimes happen beneath the park, but these are usually pretty small and localized. Plus, they're usually accompanied by minor changes in the shape of the land, suggesting that magma isn't rising up toward the surface. We could be looking at something like the 2018 study suggested, where magma is entering the chamber but staying deep beneath the surface. Or we could be approaching the next eruption. It's just impossible to say without more data. As for whether it will break the planet, probably not. While it is true that Plinian eruptions can cause global cooling, it takes a lot of gas to have that effect. And even then it only lasts for a few years. During the 1815 eruption of Mount Tambora in Indonesia, for instance, about 15 cubic kilometers of gas were ejected, causing temperatures around the world to drop by as much as 3 degrees Celsius for several years. By comparison, the hypothetical mega-ultra eruption of Yellowstone would eject somewhere in the range of 1,000 to 3,000 cubic kilometers of gas. So while it would definitely cause global cooling, it wouldn't be as much as we saw during Tambora's eruption. In other words, life as we know it probably wouldn't end, but things could get kind of dicey for a few years. Additionally, while a Plinian eruption at Yellowstone would be the largest in recorded human history, it's important to remember that humans have been around for less than 10,000 years, and the geologic record shows that Yellowstone has had at least 3 major eruptions during that time. If humans were wiped out by an eruption 10,000 years ago, we might not be here today to worry about it. So no, Yellowstone probably won't break the planet, but it's certainly capable of changing it in ways big and small. It's just up to us to keep studying it so we can better understand what it might do next. When it comes to science, there's always more to explore. And if you're curious about what else is out there, you might want to check out some of the amazing educational content from a digital studio. And thanks to all of our patrons for supporting this SCI Show video. You guys